everyone. Today we're going to talk about the fundamental theorem of algebra. So the fundamental theorem of algebra tells us that if p of x is a polynomial of degree n is greater than or equal to 1, then p of x equals 0 has exactly n roots, including multiple and complex roots. So what this means is that the degree of a polynomial tells you how many roots the polynomial has in total. Some may be real and some may be complex, and some may be repeated. So let's practice finding the zeros of a polynomial function. So number 1 says, how many solutions does the equation x cubed minus 6x squared minus 15x plus 100 equals 0 have? Find all the roots. Well, I see since this is a degree 3 polynomial, that means that this equation has 3 solutions. Okay, and now we're going to go ahead and find these solutions. So to do that, I'm going to go ahead and use what we talked about in our previous lesson on rational roots. So my p here is 100, my q here is 1. So looking at possible roots, it's just going to be my factors of 100. So my possible here is going to be 1, 2, 4, 5, 10, 20, 25, 50, and 100. So I like to always just go ahead and start with 1 and do synthetic division and see if that one works, and then go up from there. So starting at 1, and then I need to put my coefficients here of my polynomial. My coefficient of x cubed is 1, of x squared is -6, of x is -15, and then 100. And if you recall, to see if 1 is a solution, I'm looking for the remainder to be 0. So I'm going to bring down the 1. 1 times 1, I get 1. -6 plus 1, I get -5. 1 times -5, I get -5. -15 minus 5 is -20. 1 times -20 is -20. And I see this does not end up equaling 0. So now I'm going to move on to -1. -1 times 1, I get -1. These add to -7. I get +7. This adds to -8. I see this is also not going to get me 0. So now I'm going to move to 2. 1 times 2, I get 2. -6 plus 2, I get -4. 2 times -4, I get -8. -15 plus -8, I get -23. 2 times -23 does not give me -100, so it is not 2. Now we'll try -2. And so I'm just going to keep going. Nope, not -2. Now we'll try 3. -15 minus 9, I get -24. That also does not give me -100. So it's not 3. Now we'll try -3. -27 minus 15, I get 12. Nope. Now we'll try 4. 1 times 4, I get 4. -6 plus 4, I get -2. -8. -23. This one's really close. I get -96, but not quite there. So now we'll try -4. And I see that -4 gets me my answer. So that means I have x plus 4 since -4 ended up giving me a 0 remainder. And then writing 1, negative 10, 25 as my polynomial, that's going to be x squared minus 10x plus 25 is equal to 0. Now I need to factor this x squared minus 10x plus 25. Well, two numbers that multiply to 25 and add to negative 10 are going to be x minus 5 and negative 5. And so now I can solve x plus 4 equals 0, x minus 5 is equal to 0, and I get x equals negative 4, and I get that x is equal to 5. And so those are going to be my answers. However, we said that we're supposed to get 3 solutions, and I only see 2 here. Well, that is because my x minus 5 shows up twice, so this 5 has multiplicity too. So there are 3 solutions. Okay, let's look at another one. Here says, how many zeros does the equation x to the 4th plus 2x cubed minus 13 x squared plus 10x equals 0 have? Find all the zeros. So here, this one is a 4th degree polynomial, so that means that this one has 4 solutions. Now, looking at this one, I see that I don't actually have a constant term. It's just going to be 0 at the end because my last term here is 10x. So because of that, I can actually go ahead and start with factoring out an x. So I already know that one of my linear factors is going to be x minus 0, or in other words, the solution is going to be 0 because of that x that we factored out. But now we need to figure out more solutions from this other polynomial. So here I want to go ahead and use my rational root theorem. My p here is 10, my q is 1, so that means my possible roots are just going to be the factors of 10, which are 1, 2, 5, and 10. And now I'm going to use synthetic division to figure out which is a root. So I'm going to start with 1 again, and my coefficients here are 1, 2, negative 13, and 10. So I bring down the 1. 1 times 1, I get 1. 2 plus 1, I get 3. 1 times 3 is 3. Negative 13 plus 3 is negative 10. 1 times negative 10 is negative 10. And here, 1 ended up actually being a root. So we got it on our first try. So now I have this x still out in front. 1 is a root, so I have the linear factor x minus 1. And then the 1, 3, and 10 is going to be x squared plus 3x minus 10. So first I want to see if I can factor that. So I'm looking for two numbers that multiply to negative 10, but then add to equal 3. And I say it's going to be negative 2 and 5. And so this can be x times x minus 1 times x minus 2 times x plus 5 is equal to 0. And so solving those, I have x equals 0, x minus 1 is equal to 0, x minus 2 is equal to 0, and x plus 5 is equal to 0. And solving those four, I get the answers that x is equal to 0, 1, 2, and negative 5. And so here I see I did get 4 solutions, all with multiplicity 1.